got 6 really fantastic talks coming up in the session. I think you'll really enjoy them. As usual, they're going to be 15-minute talks with 12-minute talks with 3 minutes of questions. So my name is Tim Rawback. I work here at the UNSW Centre for Climate Change Research. And my co-chair this morning is Ashish Sharma from Argonne National Laboratory in Chicago. And we also have Austin Stancy, who's here as a volunteer. Thank you very much for being here. And he's going to do the slides or the timing for our talk. So for speakers, when you see Austin hold up the signs, please follow the instructions there. All right, so I'll just launch straight into our very first presentation. Scott Collis, also from Argonne National Lab in Chicago, but returning to Sydney, his hometown, I believe. So Scott's going to talk about community research on climate and urban science, which is a Department of Urban Energy Integrated Field Lab. Thank you, Scott.
Thank you. And are we able to get the slides up on the screen? It would help. And do we need to start recording as well?
You're recording.
The recording has started. Perfect. Thank you, everyone. Thank you so much for being here so early in the morning. Thank you very much to the conference chairs for organising a conference and giving me an excuse to come back to my old hometown. I saw it came up and said, I'm going to that one. So I am representing a very, very large group here, and this doesn't even cover it. CROCUS is a massive endeavour with many people, and I am representing the whole project. None of this is my own work. Just like Darren said yesterday, we are really early. This is going to be a results-thin talk, but hopefully something to get you very excited. This is all you need to know. You can leave after this slide. These are the take-homes. The Community Research on Climate and Urban Science is a new community-led project centered on understanding climate impacts and science in Chicago. Chicago, and this is the theme of this session, is impacted by a gamut of severe weather. When I moved to Chicago, I couldn't believe I was living in a place that could get blizzards and tornadoes. A major focus of CROCUS is understanding and quantifying the impacts of nature-based solutions on ameliorating the worst impacts of climate change in the city. CROCUS is one of 4 of the Department of Energy's urban integrated field labs. Just like BSEG, which you heard about yesterday, CROCUS has a strong community component. I got a little pointer here. Let's see if this works. Normal science that we do involves this. We come up with science questions, we'll interrogate it with a model, we'll then use observations to validate that model or build new modeling components. CROCUS has all of this over here, where we actually have community groups integrated into our research fabric, and they really not only advise them, they help us shape the science questions that are asked. So we make sure the science questions we're asking are actually pertinent and important to the communities we're working with. These are our partners here. I'm not going to go through them all, but I do want to point out waxing green, the Metropolitan Mayor's Caucus, the Puerto Rican Agenda of Chicago, and the Greater Chatham Initiative. They are our 4 community groups that we are working with. Let's see if this works. Perfect. So a little bit of motivation and context about the city of Chicago when it comes to inequality. Basically, the take-home I want from this slide is Chicago is really heterogeneous. It's flat. Boy, Sydney's got some hills. I forgot about that. But Chicago is flat, but due to the socio-economic nature of the United States of America, it is heterogeneous in terms of societal outcomes. This is a great slide here, a great plot here from Ashish, where you can see roof temperatures, AC consumption, and heat vulnerability index. And you actually can just see the heterogeneity. It can change from one suburb, one postcode or zip code to another. This plot here actually shows where the partner communities we're working with. Metropolitan Mayor's Caucus is the whole area, but there are where our community partners are based. So digging into some of the science CROCUS is starting and will address. Again, I've really enjoyed being at this conference. I'm new to this community, and I'm seeing that we're well positioned to help inform some of the things that Matt was talking about on Monday. Because we really want to look at improving urban canopy parameterizations using both models and measurements, and I'll come to that in another slide. The measurements that we're playing will address critical gaps, including moisture fluxes. We heard on Monday that we can get the right answer for the wrong reasons, and we might optimize to get in a model to get one set of fluxes right, sensible fluxes, and then completely get latent fluxes wrong. So we're really going to be informed by that and build our measurement strategy around that. We're really looking at improving, I've got silence in a second, parameterization of local climate zones. If you actually look at land use classifications, it's not the resolution we need. We're developing process scale observations, looking at the actual impact of mitigation. Someone puts a green roof in, we want to get in there before, measure fluxes, measure information on it, and actually measure the change. We've got a couple of partners working on that. And we're working on integrated digital twin for the urban region, which is something we hope to build and actually have as a lasting asset at the end of the project. As was also pointed out in the excellent framing talk by Matt, we want to make sure when we're done in 5 years, we leave something behind at the end and the project just doesn't finish. So I don't want to assume everyone knows everything about Chicago meteorology, so here's a little bit of a 101. Chicago sits up here on Lake Michigan. There's the Gulf of Mexico down here. The color map here is temperature from a heat wave we had recently. One of the reasons Chicago gets so many extremes is you can be getting advection from the Gulf of Mexico in summer, and you can be getting advection from the North Pole where there's no open ocean in winter between you and the North Pole, no wonderful warm ocean that circulates around Australia here. You are getting the full brunt of any Arctic outbreak that comes down that way. In spring, when you have overspreading air aloft that is cold and warm, moist water from the Gulf of Mexico, that's tornado juice down there. This time of the year, we can actually have that area of convergence is further up, and you get your heat waves. Now, zooming in, you can see one of the real heterogeneous features of Chicago is Lake Michigan. Lake Michigan always lags in temperature. It's a huge body of water. It's very deep. There's a lot of thermal mass. In the hottest parts of summer, it provides wonderful thermal relief. So things like how far does the lake breeze propagate? How does that interact with green infrastructure? There's a massive interaction with the lake breeze and ozone and air quality due to heavy industry sitting down here at the tip in Indiana. So it's a wonderful, complicated space, a real good proving ground for models, especially given the lack of terrain and topology. So you can really take that out and focus on other things. In 1995, and this is again one takeaway that's been said before, heat is the worst form of severe weather by far. We all fixate on tornadoes, hail even. Hail's great, don't get me wrong. Heat kills more people by far. 1995, the Chicago heat wave killed over 700 people, and it was dubbed death by postcode, or zip code, because we're in the United States, because it really depended on whether you had air conditioning or not. It was a true climate disaster. I want to bring up this concept we have in the department called MODEX, or model-driven experiment. This really answers the question of how do we reduce the time in which we get new observations and their impact on models. MODEX seeks to accelerate the implementation of knowledge and predictive models by using the model itself to guide where measurements need to be taken. MODEX can be as simple as, I gotta move. Listening to a talk and saying, I need more fluxes. It can be as complicated as actually using the model for gradient stuff. CROCUS has 6 thematic groups. I'm not going to go into them here. The CROCUS modeling paradigm was brought up yesterday. We're using a multi-scale approach to modeling, everything from regional climate to regional scale, going to WRF, but then really going down to high-resolution LES and RAMS modeling. Here's a great example of where we're actually working on new land use zones, and here's some work we saw yesterday from Ashish and co, where we're also using machine learning to help really extend our observational network. And here's an example of some of the work from NEC 5000, NEC 5000, where it's actually looking at getting into that urban canyon. We can't run NEC 5000 everywhere, so we'll be doing targeted experiments with it, but then also looking at using machine learning to train emulators for DNS models as well. The measurement strategy has 4 components: a 21-node micronet throughout Chicago, a set of field campaigns, community-led science. You've got to be very careful with the word citizen science in the US, by the way. It's not an inclusive term. And also using public data. The micronet will have 21 nodes across Chicago. We are actually using models to work out where we are going to deploy those nodes. The workhorse for our micronet is actually the Weissler WXT and AQT sensors that gives us it gives us 10 hertz, all the really good information from the weather station, but also with the AQT, we get a lot of gas phase chemistry, PM1, 2.5, and 10. How good is it? We're working that out. There's a lot of advertising guff when it comes to air quality sensors. I'm going to go really quickly through these slides, but one really cool thing about CROCUS is we're actually eschewing the normal logger methodology and using edge computing to control our sensors and do our digitization. The great thing about that is we can actually program these edge nodes to both do data quality testing, retrievals, and even using things like upward-facing cameras and computer vision to do things like tracking clouds and looking at cloud cover as well. Field campaigns, we're working with the University of Illinois in Urbana-Champaign and the University of Wisconsin. We're bringing the tornado-chasing Dow radars to look at urban hydrology. We need to get much higher resolution rainfall retrievals. We have 2 minutes, are we, or where are we? Perfect. We're going to have about 4 field campaigns throughout a 5-year project timescale. Really, in our second last year, it's going to be a massive field campaign where we're going to be down there for months and months and months, collecting high-resolution data, launching sounding, looking using wind sondes, profilers, high spectral resolution LiDAR systems, so on and so on, to really fully characterize the 4-dimensional interaction between the atmosphere, subsurface hydrology, biogeochemistry, including the health of trees, in Chicago. We had an inadvertent zeroth field campaign in August where the NASA, STAX, and Aroma campaign, they were originally focusing on California and New York, but they kind of thought, well, we've got to do Chicago as well because our base out of Ohio. And so we actually had the DC-8 flying low and slow over us, doing these really cool transects about 1,200 feet. I'm sorry, I'm not going to do the meters converted in my head right now. This is a mobile air quality laboratory. So clearly I discussed this yesterday about air quality. This is the data set. And we actually had a whole bunch of other assets, ozone sondes, ozone LiDARs in the area. Just a really initial introduction to some of the data we're collecting. As soon as we put our sensors out there at Northern Illinois University, we had wildfires in Ontario, biggest wildfires ever in Canada's history. That led to, we don't even know whether it was the worst air quality ever in Chicago, but it's definitely the worst air quality we've ever observed. 300 micrograms per cubic meter. We saw up there safe, but EPA, 13 for sensitive groups, 25 for healthy groups. This was many, many times that. And you actually can see our salometer data down here, where we can actually see the depth and structure of that smoke layer. It's going to be a great data set for looking at settling and all kinds of physics. So, conclusions. CROCUS is a unique project that will improve the representation of the urban environment in climate models and bring a lot of science to this. We're going to be collecting our comprehensive and most importantly, open. CROCUS is going to be the open blueprint for doing urban science all the way when we run the instruments. Our setups will all be open as well. Our data portal is open. Ping me later. If you just Google CROCUS, DOE, you'll get the right thing. And with that, thank you very much for your time.
Thanks so much, Scott. Do we have questions from the audience?
Yes.